Okay, let's go ahead and look over these three problems. The first one says, what kind of function models the table and create a function rule? What are those x's changing by each time? 1. Are we adding 1, multiplying by 1? How are they increasing? Adding 1 each time. So that's a constant first difference in our x's. What about the f of x's, the y's? What's happening there? They're multiplied by 2? Is that what you're going to say? Oh, yeah, I see how that could be a little bit tricky, but it is multiplying by 2 each time. What kind of a function model do we use when we're multiplying by the same amount each time? Linear is a good guess. Linear is when we have a constant rate of first difference in x and a constant rate in y, but this one is multiplying by something for y each time. Quadratic, we've talked about quadratic. Quadratic is when we have a constant first difference in x's and a constant second difference in y's. What's the third one? We talked about it on Wednesday. The exponential one. But those are the three that we go through when we look at a table. We think, is this linear? No. Is this quadratic? And then this one is going to be an exponential function. And that's of the form f of x equals a times b to the x. What's our b here? What does our base mean? Yeah, our base is what it's multiplied by every time. So in this one, our base is 2. It's what we're multiplying by every time. What does a represent in an exponential function? What is our a?
It's what you start with.
It's what we start with, yeah. Where do we start on this table?
6.
At 6. How do we know it's 6?
Because it's with 0.
Because it's with 0, yeah. So this one happens to also be the first pair that we see, but the really important part there is that 0 is x. It's our y-intercept. So that is our function rule for the table. Number 2, we're writing an expression that is equivalent to this whole mess. Oops. What can we do first? What do we do with everything that's in those parentheses? We have, it's all raised to the third. That 3 in the exponent is going to be applied to everything in the parentheses. So we have our 3 to the third, our x to the third. What do we do with the 3 in the exponent for the y? How do we add that 3?
Use that.
Do we add them? I misused that word. But what do? I'm not going to add them. We're going to multiply anything that's raised to the power. When we have an exponent already and it's raised to another exponent, we multiply those together. I'm going to tack on that x to the 5th too, because we don't need to do anything with that yet. What about that last y to the -3? What do we do when we see a negative exponent? We got to bring it down, and what else? What do we do with that 3?
You just switch it to positive.
Yeah, we just make it positive. Perfect. What's 3 cubed? Does anyone know it off the top of their head? Or from their calculator? What's that? 27, yeah. 9 times 3, I heard you getting there. Do we have like terms with x's that we can combine?
So you can combine the x3 and the x5.
We can combine the x3 and the x5. How do we combine those?
Add it.
We add them. Then we have y, and we'll do that simplification to have y to the 9th. And we still have y cubed on the bottom. Let's do one more step to simplify that further. We'll bring that 27 over. X to the 3 plus 5 is going to be x to the 8th. What is y not to the 9th over y to the 3rd? What do we do with those exponents? We subtract them, yeah. So it's going to be y to the 6th. And that's the simplest we can get because there's no like terms in there anymore. The third problem says Olivia's math homework doubles every 3 days. If she has 128 problems assigned to her 15 days into the school year, how many were assigned on the first day of school? That's a lot of information all at once. So let's look at it piece by piece. What is the first thing they tell us? That her homework doubles, yeah. What does it mean when something's doubling? We're multiplying by 2. What function model do we use when we're multiplying by the same amount every time? The exponential. We used it up above. So that's going to be our base. So now that we know which function we're using, we know what information we want to look for. We already know that our base is 2. The next thing they tell us is that it's happening every 3 days. That's how frequently it's happening. This is the weird one where we just know that it's going to give us our exponent is x over 3. Because x is the amount of time, and it's happening every 3 days, so we have to divide it by 3. What else do we know?
She has 128 problems assigned to her 15 days into the school year.
We have 128 problems after 15 days. What do those mean? So 128 will be the final amount when our x is 15. So what's our a? Do we know what our a is? No, we have to figure that out because they're asking us how many she had on the first day of school. So we want to find that initial value. We want to find a. What can we put in for f of x and x so that we can solve for a? What do we know that we haven't used yet? How many problems have we talked about? We've talked about 128 problems for how many days? 15. So if 128 is the amount of problems, that's our final amount, we can plug it in with our 15 for x. What's 15 divided by 3? It's 5. Not a trick question, I promise. And do we know what 2 to the 5th is, either from our calculator or from our head? $32? Yeah, it's 32. And then what's our last step to get rid of the 32 and get our a alone? Divide both sides by 32. And we'll get four. So on her first day of school, Olivia was assigned 4 problems. Last thing we're going to do, put it in the grid. We just write 4, and beneath it, we bubble in our 4. What questions do we have about the bell work problems?
It's on the lower thing.
Mhm.
You have to be on this side, or you can just do the.
I'm pretty sure you can be either all the way to the right or all the way to the left.
Oh.
Okay.
Just don't put it in the middle.
Don't put it in the middle. Okay. So we are going to turn to page 58. And we're going to talk about compound interest. Has anyone heard the word compound before outside of math class?
Yeah.
Yeah. Where have you heard it before? In English class?
It's on the internet.
On the internet? In science? What?
Just like when somebody's talking about two things.
Yeah, when it's talking about 2 things. So in English class, we talk about compound words. And that's when we put together 2 words and combine it to make another. So like sun is a word, flower is a word. Sunflower is a compound word. We're putting 2 together. Percent is a compound word. Per is a word. It means for each. Cent, how many cents in a dollar? 100. Cent means 100. So percent means for each 100. What does interest mean? What are we talking about when we talk about interest? What's that? To give more. So when you put money in a bank, over time, they want to pay you for keeping your money there, so you gain interest. So I start with this amount of money. After a certain amount of time, I gain interest. So I add that to what I already had. After the same amount of time, I earn more interest. I add that to all of it. So when I earning interest, I'm putting it together. Compound interest is what we talk about when we're putting all the interest we're earning together. This is our formula for compound interest. A lot of it looks pretty familiar. It's similar to what we've been talking about before. Our A is going to be our final amount. That's similar. Our P is our principal or starting amount, which we also know is our y-intercept. Our rate is R, and that's always going to be written as percent over 100. Our T is still going to be time, how much time is passing. But the new variable we have is N. What N is going to mean, and it shows up twice, is the number of times that something is compounded. So it's going to be the number of times that I'm earning interest. And because interest is all about money, we got to remember that when we use money, how many decimals do we round to? What's the smallest amount of money we can have? A penny. And a penny is going to be in our second decimal place, our hundredths place. So we're going to round, oh my goodness, to the nearest penny when we write our answers. And write 2 decimals. So now that we know what each of those variables are going to represent, let's look at a problem. Suppose Laura invests $4,800 in an account, earning 4.5 interest. How much money does she have after 20 years if we're compounding annually, quarterly, weekly, and biweekly? So, what do we know? What does it tell us first? She has 4,800, and what does that mean in our equation? It's P. That's our starting amount. That's what she starts with. What's the second piece of information we know? The rate. What's our rate? 4.5. Would we write 4.5 into our equation? No. What do we have to do? We got to divide it by 100. Which would be 0.045. What else does it tell us? What is it asking us? Time. How much time is passing? 20 years. Yeah. So our time is going to be 20 years. How many times do you celebrate an anniversary? Once a year. That's happening annually. So if something's compounded annually, how many times is it happening per year? Just one time. So annually means once per year. That means our n is going to be 1. So we're going to go ahead and just put all of those pieces into our equation. So our P is 4,800. And we bring that 1 plus down. We said our rate was 0.045. And what's our n? 1. So we put that over 1. And we raise that to the 1 times 20. 20 was our time. So, everyone should have a calculator in front of them. If you don't, you can pull up Desmos on your phone, that graphing calculator, or we can just pass them along once we're done. What's going to be really important is that you practice putting these equations into your calculator, because on a test, you will need to know how to use your calculator to find this answer. So, the easiest way to do this, we could technically simplify it and divide in the parentheses and do all that. That's going to just be kind of a hassle and give us some weird numbers. So what you're going to do is after you write this equation, you stop writing and you just put the whole thing into your calculator. So I'm going to come around and have everyone show me that they've gotten the right answer in the calculator. What you're going to do is put 4800, those keys, an open parentheses, 1, the addition sign, the fraction key. Can I borrow? The fraction key is the third row down, the second key in from the left. And it says n over d. It says n over d. When you press n over d, you'll use your arrows to fill in your fraction, and then you'll use your right arrow to get out. You'll put the closed parentheses, and then you'll use the exponent button. The exponent button looks like a little arrow up, and it's 1 up from the 7 and over to the left. Okay, I'm going to come around, and I want everyone to show me that they've gotten this answer in the calculator, and if not, then we'll work on it.
I got a different calculator.
Okay, I'm going to borrow this and bring it back. Use this guy. Practice with this one.
Because you can be confused when you go that. This one, wait, is this one?
That's going to be the fraction one, but you're going to start with 4,800
Okay.
and then do everything you see.
Oh,
Okay, so after you do this closed parentheses, do this up arrow, and that'll give you to the exponents. And then press enter. Perfect. So give you that E in there that you don't need. So delete the E.
Thank you.
We'll start over. Or not start over. Go delete those.
Delete this.
Mm-hmm. Okay, and then we're going to go this up arrow. That's going to take you up. And then you do 1 times 20, and you press enter. There you go. This one doesn't work? So, Kyle, can I borrow this for a second? Nice. Good work. So, write everything that you see up there, starting with the 4. Mm-hmm. Okay, so now, well, first of all, this is 0.045, but that's okay for now. This exponent, that'll get you up. There you go, and then you write 1 times 20. Okay, so just the last piece up there is up to the 1 times 20. Like that. After the parentheses, so that's this button. Okay, so we'll restart, we'll write the whole thing again, but this part is writing. So let's clear it and rewrite it, and then after this part, 1 times 20. When you get a chance, will you borrow Issa's? Perfect. Okay. The exponent button is right there. And then do the 1 times 20. Okay, so you're going to use these arrows to move. There you go. So you're going to do 4,800. And then you're just going to copy everything you see there. Oh, oops. Wait, what's there? Right there. You need the 1, so let's go back. Right there, 1 plus. And then we do the fraction. And then we use these arrows, we go down. 1, and then we go to the right. And we do the parentheses. And then we go here to get the 1 times 20. Oops, it's just 1. There you go. And then we multiply by 20. And enter. Okay. Anyone else have any questions? Okay.
How to get the exponent?
Okay, the exponent is that up arrow. Yeah. All right. So, will someone read to me what they got?
11,576.2.
Point what?
0.2.
Point 2. Okay, but what do we say when we have money? How many do we round it to? To what? A penny. So how many decimal spots do we have? 2. So what's our second decimal?
2.
And is that rounded? I think we need to round it up. One more. So it'll be okay. What does it mean for something to happen quarterly? How many? 25. Okay, so a quarter is 25 cents. How many quarters in a dollar? 4. So if something is happening quarterly, it's happening 4 times. There's 4 quarters in a dollar. So this means that it's happening 4 times per year. And that'll be our n is 4. How do we start our equation? A equals, what's that? Yeah, exactly. We're going to use the exact same numbers, but change our n. So we bring our principal value down, our p. Then we bring our rate down. It's the same equation that we're writing down. Our rate is the same, but our n will be different. And then this is where we stop. We don't simplify anymore, and we put it into our calculators. And when someone has a value, let me know. You got one? Great. Okay. We got 11,746 point how many? Would it be just 9? How many do we round to? 92. Yeah, we round to our 2 decimals when we have money. Because we can't just have part of those coins. All right, the third one is compounded weekly.
7.
There are 7 days in a week. We're talking about how many times this is happening per year. 5, okay. How many weeks are in a year? 52. So if something is happening every week in a year, it's happening 52 times. Because we're always talking about if we're compounding annually, that's once per year. Compounding quarterly, 4 times per year. We're always talking about how many times per year. So our n will be 52. But it's the same problem that we're dealing with, so we just bring down every number the same. And we replace our n with our 52. Andre, do you have an answer?
Mm-hmm.
Could you read it to me?
11,801. And then 50 cents.
Point 50 cents. Nice. Okay. Our last one says compounded bi-weekly. What does that mean? What does bi-weekly mean? It means every 2 weeks. Yeah. So if something's happening bi-weekly, how many times is that happening per year?
Two times a year? Like 2 weeks a year? Is that what you mean?
26. How'd you get 26?
I divided it.
What'd you divide?
52 by 2.
Yeah, so it's happening every 2 weeks. We have 52 weeks in the year, so we divide 52 by 2. So it's 26 times per year. We always have per year. And our n is 26. But still same problem for Laura, so we're just get to use those same values. And put 26 in for our n.
Um, 11,796.91 cents.
You got 92 cents? Okay, so how do we know when to round? We look at the next one, and if it's at 5 or above, we'll round up.
Keep it the same.
If it's lower than 5, we'll keep it the same. So we're going to keep that as 91 cents. Okay, good work on that one. We're going to move down to the next problem. It says the first credit card you got after college has an interest rate of 22.62%. If you max out the card by spending $1,200 but make no payments for the first year, how much would you owe at the end of that year if the interest is compounded? Whew, that's a lot. What's the first thing they tell us?
The rate.
The rate. 22.62, but is that how we would put it into our equation? We divide it by 100. Every time we see that percent in a rate, we're going to divide it by 100. What does that give us? Yeah. So that is our rate. What's the second piece of information we know? Yeah, the starting amount. In this one, it would be the P. Yeah. That's what we started with. That's our P. But we made no payments for the first year. So what is our time? What's our T? A year. Yeah, so how many times? It's 365 days, but it's just 1 year. So our time is going to be 1. All right. Compounded semi-annually. What does it mean to do it semi-annually? How many times per year? What was that?
Annually is 1 time. What's semi?
Like you don't have today.
So semi-annually, you said annually is 1 time. Semi-annually is going to be 2 times. So semi is just part of the whole year. Some of these you're just going to have to know that, bi-weekly means every 2 weeks, but semi-annually is twice a year. All right, so we have a new equation. What's our P? 1200. We bring that 1 plus down. We said our rate was 0.2262. And if it's happening twice per year, that's n equals 2. And our time is 1. So this is the part where we stop writing and we put the whole thing into our calculator. And what do we get?
1,486 and 79 cents. Well, 89 cents.
And 89 cents?
80 cents.
I'm going to leave it as 79. I think that's, you were right on it. Okay, let's just talk about what our ends would be for these last ones. If something's happening monthly, how many times per year? 12 times per year. So we would put n equals 12. Compounded bi-monthly. This is one of those that you're just going to have to remember, and it's kind of weird. We said bi-weekly was every 2 weeks. Bi-monthly is going to be twice per month. So if something's happening bi-monthly, how many times in a year? 24. It's happening twice per month for 12 months. So it's 24 times per year. If it's compounded daily, that's where we have 365 times per year. And our n would be 365. Good work today. We have homework 3 is due on Tuesday. Only part of it is stuff we've talked about yet. So you can either go ahead and do some of that and then wait till Monday when we talk about the second half. Or if you haven't done homeworks 1 and 2, which were due yesterday and today, maybe you can spend that extra time going back and looking at those.
One quick note, guys, on the daily, monthly, bi-weekly, semi-annually. You want to work on remembering those pieces, but I don't expect